Hey, welcome back everybody. I left you with this nasty cliffhanger where I challenged you to write a recursive function that kind of tried to run a future-based computation n times without the recursion. Okay? Now, I'm going to show you two possible ways to solve this. But of course, you know, maybe you have come up with your own way and you can share that on the forums. That would be fun. What I'm going to do is I'm going to use fold R and fold left. Those are the kind of, you know, two power tools in our toolbox. And whenever we do things with recursion, it's often nicer to do it with a fold. Okay, so let's see what the consequences of this are, because maybe using a fold is not always the correct choice. Okay, so let's geek out for a bit and pretend that we are functional programming hipsters. I should put on here my, my rimmed glasses and my tweed coat, but I remain a hippie in my tie-dye. But what we're going to do is we're going to use fold right and fold left. So let's refresh our memory what these are. Fold right takes a list, in this case list with values a, b, and c. It takes a neutral element, e, and a function, a combination function. Okay? And this fold right folds the list from right to left. Okay? So it starts at the right side of the list and then takes e and applies f to c and e. And then it goes one step to the left, because it's folding from right to left, and then applies f to b and the result of c and e. And then finally it applies f to a and the result of folding from the right. Okay? So it's easy to remember. It's just like the northern wind blows from the north, folds right, folds from the right. Obvious, huh? Then if we look at fold left, well, that folds from the left. So what it does is it starts with a neutral element and it has the combiner function, and it first combines e with a and then combines that with b and then combines that with c. All right, so it kind of associates the other way around. We're going to use both fold left and fold right to implement our function to retry a computation. And here is the solution. So what we're going to do is, well, if we want to use fold, and in this case we'll start with fold left. If we want to use fold, we need a list. Well, how do we create a list? I know. We can create a list from number of times. So what we will do is we'll create a list from 1 to number of times and put that into a list. Then we will map over that list the block. So now we get a list of n blocks. And notice that we're kind of putting that block under a unit arrow because we don't want to execute a block just yet. We want to execute them one by one because every time we execute it might have side effects. So we have to be very careful to delay the execution of the block. Our neutral element is failed. So we create a new future failed. And then what we do is we fold from the left, starting with failed. And then our combination function takes a future. That was the thing on the left, and the block, and then we try to run the future, and if that fails, we're going to run the block. Okay, so it looks a little bit puzzling, but if you think a little bit about it, retry tree of block will unfold to failed, recover with block, recover with block, recover with block. If you don't believe me, let's do the derivation here. So first, we're going to run the list. So we get, that's the simple thing. So when we run the list, now we're going to map the number of attempts over that. So now we get a list of n blocks. And remember, this is super important to do this here because we don't want to accidentally execute the blocks. Okay, so we have to build this little thunk that hides the block. All right, and now we're going to fold left. And if you kind of do the fold left here, you will see that this gives us the same result. So by doing a little bit of substitution, it should be clear that the result of this function is exactly what we want. All right, now let's try to do it with fold right. There's even more higher order functions. So in this case, again, we create a list from 1 to n. We map the block, delayed block over that. We create a failure, but now we're folding from the right, starting with failed, but we're not really starting with failed. We're starting with a function that is delayed failed, because we kind of have to turn this from the other side. So what you will see is the combination function now takes a block on the left and a function that returns a future on the right, and we have to return a function that returns a future. And how do we do that? By calling the block and then falling back to the A. So here you see that everything is reversed, and when you unfold this, you will see this here. So this is like, looks like super cool with lots of higher order functions. But to be honest, I think that in this case the recursive solution was the simplest one. All right? So sometimes straight recursion is the way to go, and we should just leave those higher order functions to the functional programming hipsters, right? And this is one of the most important things of mastering programming. You have to know when you use recursion, you have to know when to use fold, you have to know when to use fold left, because you saw that fold right and fold left, the code looked quite different. And in one case we even needed more higher order functions. But this kind of balance, that is, as you get more experienced in writing code in a functional style, that's what you will learn. It will become natural to you. Just like a soccer player knows intuitively when to jump and to head in the ball into the goal. All right, thank you. This was the end of composing futures. What we're going to do next is we're going to look at some even more advanced ways to deal with futures.